Hello friends, how are you? I hope you are maintaining your good health and preparing seriously for your final examinations. Friends, you already know that who are aspiring for higher studies, that is engineering, we have to prepare for the CET also. This time there not be much time is available for the preparation of CET after your semester exams. Therefore, we have to pay the attention towards the preparation of CET along with your 6th semester subjects. In this video, we try to give some information regarding the preparation for the subject hydraulics and pneumatics. So first of all, we'll see the syllabus for this subject, fluid mechanics and pneumatic. This subject carries 17 marks and the entire syllabus is given into the 4 chapters. The first one is the basic chapters, which deals with the properties of fluids, the basic things, and manometers, the Bernoulli's theorem, its applications, etc. The second chapter deals with the pumps, both centrifugal as well as the reciprocating pump and multi-stage centrifugal pump and also submersible pump. Whereas the third and fourth chapter deals with the oil power hydraulic system and the pneumatic system. These two chapters almost they are similar to each other. The only difference is the working medium. In hydraulic system the working medium is oil, whereas in pneumatic system the working medium is air. But otherwise the content it will be easy for the preparation for the CET because almost they are similar to each other. So let us take the basics, the first chapter. What is fluid mechanics? Already you know that it is the branch of science which deals with the behavior of fluids. Fluid in the sense it includes both liquid and also the gas which is at rest and also in motion. It is also defined as the mechanics of fluids. Fluid also include the water. And hydraulic machine is another branch which deals with the machines run by the water under some load, some head or raising the water to higher levels. So first we'll know what are the different types of fluids. Fluids are basically classified into the 5 different types. The first one is ideal fluid, which is an imaginary fluid. It is incompressible and it is not having any viscosity. Second is real fluid. These are the fluids in actual practice and they have the viscosity. Third, Newtonian fluid. It is a real fluid in which the shear stress is directly proportional to the rate of shear strain. Fourth is non-Newtonian fluid. It is a real fluid in which shear stress is not proportional to the rate of shear strain. And ideal plastic fluid in which the shear stress is more than the yield value and shear stress is also proportional to the rate of shear strain. Then what are the different properties of the fluids? The first property is density, which is also known as mass density. It is the mass per unit volume of the fluid at STP, that is standard temperature and pressure. Therefore, density is equal to mass by volume and its unit is mass is kg, volume is meter cube. Therefore, unit of density is kg per meter cube. The second one is weight density, which is also known as specific weight. It is defined as the weight per unit volume of the fluid at STP. Therefore, W is equal to weight density rho into g, where g is called as the acceleration due to gravity. Its unit is Newton per meter cube, or practically it is also called as kilonewton meter cube or Newton per millimeter. For water, the weight density or specific weight is 9.81 kilonewton per meter cube, or it is also called as 9810 Newton per meter cube. Next is specific volume. It is defined as the volume per unit mass of the fluid. Therefore, it is equal to 1 by rho. Therefore, unit of specific volume is meter per kg. Unit is meter cube per kg. Specific gravity. It is defined as the ratio of specific weight of the fluid to the specific weight of the standard fluid, that is pure water, at standard temperature, that is 4 degrees Celsius. It is a dimensionless quantity, and the specific gravity of pure water is taken as 1, and specific gravity S is equal to weight density of the liquid divided by weight density of water. The another property is viscosity. It is also known as absolute viscosity or dynamic viscosity. It is defined as the property of a liquid which offers resistance to the movement of one layer of liquid over another adjacent layer of the liquid. It is due to the cohesion and interaction between the particles. The CGS unit of viscosity is poise, and SI unit is Newton second per meter square, and 1 poise is equal to 1 by 10 Newton per meter square. Kinematic viscosity. It is defined as the ratio of dynamic viscosity to the density of liquid. The SI unit is meter per second, and the CGS unit for kinematic viscosity is Stokes. Another property is compressibility. It is the property of liquid by virtue of which liquid undergo a change in volume with the change in pressure. It is the reciprocal of the bulk modulus of elasticity. Therefore, compressibility is 1 by K, where K is called as bulk modulus of elasticity. Another property is surface tension. It is the property of a liquid which enables it to resist tensile stress, or it is also defined as the tensile force acting on the surface of a liquid in contact with a gas. Surface between two immiscible liquids such that the contact surface behaves like a membrane under tension. Its unit is Newton per meter. Another property is capillarity. It is a phenomenon of rise or fall of a liquid surface in a small tube held in a liquid relative to the general level of the liquid, when the tube is held in a vertical position. The rise or fall height is given by H is equal to 4 sigma cos alpha divided by W into D, where D is diameter of the capillary tube, alpha is the angle of contact of the liquid, and sigma is the surface tension. For water, the alpha is taken as 0, therefore H is equal to 4 sigma divided by W into D, and for mercury, alpha is taken as 128 degrees. Now we will discuss about the different types of pressure. This figure is giving you the relation between the different pressure, that is atmospheric pressure, gauge pressure, absolute pressure, and vacuum pressure. So that is the relation. What is atmospheric pressure? It is a pressure that an area experiences due to the force exerted by the atmosphere. It is due to the weight of the atmosphere or air above the surface of the earth, and in case of liquid, it is immersed by the height of the column of the liquid that it can support. Second is absolute pressure. It is the pressure which is measured with reference to the absolute vacuum pressure. Then the gauge pressure, which is defined as the pressure measured with the help of pressure measuring instrument, in which the atmospheric pressure is taken as datum. The atmospheric pressure on the scale is marked as 0. Fourth is vacuum pressure. It is the pressure below the atmospheric pressure. And the relation between these four is given by absolute pressure is equal to atmospheric pressure plus gauge pressure, and vacuum pressure is equal to atmospheric pressure minus absolute pressure. Therefore, P absolute is equal to P atmosphere plus P gauge, and P vacuum is equal to P atmospheric minus P absolute. So, very first basic law in hydraulics is or hydrostatics is Pascal's law, which states that the pressure or intensity of pressure at a point in a static fluid is equal in all the directions. That is, if the pressure is applied on a non-flowing liquid or fluid in a container or a vessel, then the pressure is distributed equally in all the directions within the container or the vessel. Now we'll discuss about the manometers and the different types of manometers. So manometers are the devices used for measuring the pressure at a point in a fluid, and simple manometers are used to measure the pressure by balancing the column of the fluid by the same or another column of the fluid. The different types of simple manometers are piezometers and U-tube manometer. Piezometer is the simplest form of manometer used for measuring moderate gauge pressure of liquids. Differential manometer used to measure the difference of pressure between the 2 points in a pipe. And a manometer is used to measure high pressure of the liquids, even the vacuum pressure and the pressure in the pipe and channels. So another two terms are total pressure and center of pressure. The total pressure is defined as the force exerted by a static fluid on a surface either plane or curved when the fluid comes in contact with the surfaces. This force always acts normal to the surface, whereas the center of pressure is defined as the point of application of the total pressure, that is resultant pressure, on the surface. The another important theorem is called as Bernoulli's theorem. It is also widely known as Bernoulli's equation. It states that in an ideal incompressible fluid, when the flow is steady and continuous, the sum of three energies, the pressure energy, potential energy, it is also known as datum energy, and kinetic energy, are constant along the streamline. Mathematically, it can be written as P by W, that is pressure energy, plus V square by 2G, that is kinetic energy or kinetic head, plus Z, that is called as datum energy or potential energy. So Bernoulli's equation for real fluid is given by P1 by W plus V1 square by 2G plus Z1 is equal to P2 by W plus P2 square by 2G plus Z2 plus HL, where HL is the loss of energy between the sections 1 and 2. What are the different applications of Bernoulli's equation? The devices which are working on the Bernoulli's equations are venturimeter, orifice meter and pitot tube. So what is venturimeter? It is used for finding out the discharge of a liquid flowing in a pipe. It consists of a convergent cone, a throat and a divergent cone. In order to avoid the tendency of separation at throat, there is always a fixed ratio of the diameter of throat and pipe, and it varies from 1 by 3 to 1 by 2. In order to avoid the tendency of breaking away the stream of liquid and to minimize the frictional losses, the divergent cone is made longer. Normally, the divergent cone is 3 to 4 times longer than the convergent cone. The second one is orifice meter. It is used to measure the discharge in the pipe. It consists of a plate which is having a sharp edged circular hole, and that hole is known as orifice. This plate is fixed inside the pipe. The third is pitot tube. It is used to determine the velocity of flow at the required point in a pipe or stream. It consists of a glass tube which is bent at an angle of 90 degrees. Now, what are the limitations of Bernoulli's equations? While deriving the Bernoulli's equation, some assumptions are made, so which are not practically applicable. The first one is, while using the Bernoulli's equation, only mean velocity of the liquid is taken into account, but practically it is not possible. While using the Bernoulli's equation, all the external forces are neglected, but practically it is not necessary, it is not neglected. Even though in an actual practice during turbulent flow, some kinetic energy is converted into the heat energy, and in viscous flow, some energy is lost due to shear forces. But in Bernoulli's equation, such all losses are neglected. And if the fluid is flowing in a curved path, the energy due to centrifugal force is not considered while deriving the Bernoulli's equations. So therefore, these are some of the limitations of Bernoulli's equations. Now, loss in a pipe when the fluid is flowing or flow through pipes. So we all know that when the fluid flows in a pipe, so there are different types of losses, and usually these losses are mainly classified as major energy losses and minor energy losses. So major energy loss means this loss is due to the frictional resistance offered to a flowing fluid inside the pipe, and the major energy loss can be calculated by either Darcy's formula or by Chase's formula. And the minor energy losses are the losses occurring at the entry of the pipe, inside the pipe and exit of the pipe due to the sudden expansion of the pipe, due to the sudden contraction of the pipe, due to the bend in the pipe, due to the pipe fittings and abstraction in pipe. Now we will take Darcy's and Chase's equations. So Darcy's equation for loss of head in pipes, actually it is in the two form. First one is HF is equal to 4FL V square divided by 2GD. HF is equal to 4FL V square divided by 2GD. And second one is HF is equal to 4FL Q square divided by 3D raised to 5. HF is equal to 4FL Q square divided by 3D raised to 5. Equation 1 is used when the velocity of water in the pipe is known, whereas equation 2 is used when the discharge in the pipe is known. The Chase's equation for loss of head in the pipe is phi is equal to C into square root of mi. Phi is equal to C into square root of m into I, where V is the velocity of water in the pipe, m is hydraulic mean depth, I is equal to the loss of head per unit length. So therefore, I is equal to HF by L, and C is the Chase's constant. So another two important definitions when we are studying the flow through pipe is HGL and TEL, that is hydraulic gradient line and total energy line. The figure shows the two lines how they are measured. So hydraulic gradient line is the line which gives the sum of pressure head, that is P by W, and datum head, that is Z, of a flowing fluid in a pipe with reference to sum of the reference line. In the figure we have taken the reference line as a center line of the pipe, whereas the total energy line is the line which gives the sum of pressure head P by W plus datum head, that is Z, and kinetic head, that is V square by 2G, of a flowing fluid in a pipe with respect to some reference line. So another important term is water hammer. What is water hammer? It is a knocking noise heard in a water when a valve is turned off suddenly. It is due to the sudden rise of the pressure in the pipe when the valve is closed. So these are some of the terms we have discussed about the first chapter. In the next video, we will continue regarding the second, third and the fourth chapter. Thank you.